Let's take a look at another example. Let's say that f of x is 1 minus 1 over the square root of x. So what's our domain here? Well, what can go wrong? I could divide by 0, or I could have a negative number in the radical. So this tells me that x must be greater than 0. Can't even be equal. So my domain is going to be 0 to infinity. All right, and let's go through and compute our derivatives. So f prime of x is going to be equal to, what is that, 1/2 x to the negative 3/2. As I said, I'm skipping steps, so you should be able to derive this yourself. Make sure that you can. And the second derivative, f double prime of x, will be negative 3/4 x to the minus 5/2. So let's make our sign graphs. So sign graph for f, we only need to compute for 0 to infinity. So f prime starting at 0. What are my critical values? Well, the only place where the first derivative is undefined, since this is a negative exponent, is going to be at 0, which is outside of my domain. Everywhere else in there, take any value in here, the function is going to be positive. F prime is positive here, which means we've got a function that's increasing. No maxes or mins. How about for f double prime? Well, f double prime, again, we only need to start from 0 on. And again, same issue. This is a negative exponent. The only place where this is undefined, or it's never 0, and the only place where it's undefined is at 0. And if I put positive values for x in there, it's going to be negative. So everywhere in here it's negative, which means that my graph is going to be concave down in that region. So in this domain, there's no places where we've got discontinuity. We do need to look at the end behavior. So let's look at the behavior of f as it approaches 0 and as it approaches infinity. So the limit as x approaches 0, and it's going to have to be from the right, since negative numbers are outside of my domain, and I'm looking at 1 minus 1 over root x. And if I'm really close to 0, the bottom is an infinitesimal. And so this is an infinite number. It's a negative infinite number. And so 1 minus a negative infinite number is negative infinity. It's going off to negative infinity. On the other side, if I look at the limit as x approaches positive infinity of 1 minus 1 over root x, well, now x is an infinite number, positive infinite number, which means this is an infinitesimal, and 1 minus an infinitesimal is infinitely close to 1. So I've got a vertical asymptote at x equals 0, and I've got a horizontal asymptote of y equals 1 again. And we now have enough information. We can glue this all together to sketch the graph. So I'm looking at, I only need positive values. So here's x, here's y. What do I know? Well, I know I have a horizontal asymptote at y equals 1. So let's say right here. So I've got a horizontal asymptote at y equals 1. I know that the graph will go to negative infinity as it approaches 0, and it's going to approach 1 this way. Let's look at increasing, decreasing. So I know that it's increasing on the entire domain, and it's concave down. on the entire domain. So let's just put that in here, that it is increasing all the way through, and it is concave down all the way through. So, couple questions. First off, where does it cross the x-axis? I know it's continuous through here, so it's gonna have to cross the x-axis. So when does that happen? Well, when does 1 minus 1 over root x equals 0? Well, that's pretty straightforward. You could work this out algebraically, but that's when x is equal to 1. So I'm gonna cross the x-axis when x equals 1, say right about here. So I'm going to cross there. Does it ever cross the horizontal asymptote? Well, just like we argued before, if it did, if it were to cross over, we know it's going to have to turn around and come back. Well, if it comes back, it's decreasing there. But my function is never decreasing, it's always increasing. So that can't happen, which means my graph can't ever cross this horizontal asymptote. So, and it's always concave down, so I put this all together. I know that my graph has to look something like this. Concave down, always increasing, crosses at 1, approaches y equals 1 in the limit. That's the graph of y equals 1 minus 1 over root x.